Bismillah ar-Rahman ar-Rahim. The lecture is about heat and cold in medicine. Physical basis of heat and temperature. Measure of temperature or thermometry. Mapping of the surface temperature of the body, or what is called thermography, a diagnosis tool, and heat therapy, cold in medicine, cryogenics and cryosurgery. These are the parts of our lecture. Physical basis of heat and temperature. We should try to understand the temperature from molecular scale. Molecules are in motion in a gas and liquid. Even in a solid, the molecules have some motion about their sites. The fact that molecules move means that they have kinetic energy, and this kinetic energy is related to the temperature. The average kinetic energy of the molecules of an ideal gas can be shown to be directly proportional to the temperature. Liquid and solids show similar temperature dependence. Temperature scales and thermometry. Temperature scales. There are 3 temperature scales, one of them by the scientist Gabriel Fahrenheit with symbol F, Anders Celsius with symbol C, Lord Kelvin with symbol K. These 3 scales differ by A, the basic unit size or degree, B, zero temperature. All measures are defined by freezing point and boiling point of water at standard atmosphere or atmospheric pressure. Freezing point of water 0 Celsius or 32 Fahrenheit. Boiling point of water 100 Celsius or 212 Fahrenheit. Range freezing to boiling point of water Celsius 100 degrees Fahrenheit 180 degrees. Normal body temperature is about 37 degrees Celsius or 98.6 Fahrenheit. Kelvin temperature scale. Kelvin scale is the absolute scale. It is directly proportional to the average kinetic energy in ideal gas. It fixes the absolute lower limit of 0K, which is unique temperature equals to minus 273 degrees Celsius. It's called the absolute zero. Theoretically, the ultimate in cold is absolute zero, but it is experimentally unattainable. Kelvin temperature scale has the same basic unit size as Celsius. So the freezing point of water 273 K and boiling point of water 373 K. Converting temperature between the three scales, Celsius to Fahrenheit, Fahrenheit to Celsius, and Celsius to Kelvin, by these written equations. And we notice that the Celsius and Fahrenheit scales allow for negative temperature, while Kelvin doesn't. Application. In the oral environment, temperature is not constant because hot and cold food, drink, and air. Dental pulp is sensitive, may be damaged if its temperature increases more than 5 degrees C. So the dental drilling rises in temperature of pulp during drilling should be less than 5 degrees C. Exercise. Body temperature can increase from 98.6 F to 107 F during extreme physical exercise or during viral infection. Convert these temperatures to Celsius and Kelvin and calculate the difference in each case. Thermography. Mapping of the body's temperature. Measurement of body surface temperature indicate that the surface temperature varies from point to point depending on 1. External physical factors, 2. Internal metabolic processes, 3. Circulatory processes near the skin. Symptomatic of abnormal condition, pathologic conditions. Obtaining a thermogram is to measure the radiation emitted from the body. At body temperature, the emitted radiation is in the far infrared IR region of the wavelengths much longer than those observable by the human eye. The IR or body heat radiation convert to an electrical signal. Then the cathode ray tube CRT displays the different body temperatures as different shades of gray or colors. Heat therapy. The primary therapeutic effect that plays in the heated area. 1. There is an increase in metabolism resulting from or in a relaxation of the capillary system. There is an increase in the blood flow as blood moves in to cool the heated area. Cryosurgery. Cryogenic methods are used to destroy cells. This application is called cryosurgery. 1. There is little bleeding in the destroyed area. 2. The volume of tissue destroyed can be controlled by temperature of a cryosurgical probe. 3. There is little pain sensation because low temperatures tend to desensitize the nerves. Safety with cryogenics. Many laboratories and hospitals that use cryogenic fluids have cylindrical containers of gases that are stored at high pressure. Such a cylinder can be dangerous if its valve is accidentally broken off. So these containers should be handled with care and chained in position. Caution should be exercised. Caution should be exercised with cryogenic liquids or cold gases are used because any contact between these materials and the eyes or the skin results in freeze burns. Thank you.